Autodesk's vision is to help imagine, design and create a better world, but what does all that really mean? If you've ever driven a high-performance car, admired a towering skyscraper, used a smartphone or watched a great film, chances are you've experienced what Autodesk customers are doing with our software. No other company can provide the critical insight across industries that Autodesk can. Autodesk tools are used in nearly every industry where things are designed and made, from manufacturing, media and entertainment, natural resources, infrastructure, construction, and of course, architecture. These industries face similar challenges and need similar capabilities. We're seeing a convergence of how things are designed and made across all of Autodesk's industries. Progressive construction companies are operating more like manufacturers by prefabricating and assembling things like apartment units, exterior walls, and ductwork. Media and entertainment firms are behaving more like car brands by planning and pre-visualizing their entertainment properties long before production, just like an automotive manufacturer would plan and develop a concept car. Today's transportation industry is complex, costly and crumbling. That's not news to you as you see the reports that come out of agencies like the American Society of Civil Engineers on the report cards with a grade of D for their roads and bridges. You hear about this a lot in the news, but what you don't always hear about is all of the innovation that is happening in the industry that is addressing our crumbling infrastructure, and building information modelling has been at the core of some of this innovation. BIM has been around for over a decade now in other industries, and close to 50% of new projects are using BIM at some level. Civil infrastructure owners and consulting firms have been moving cautiously toward adoption of this new way of working, as are contractors and other stakeholders that also stand to benefit. But why is now the time? There is a risk that the demand for new buildings and infrastructure will not be met due to the lack of construction productivity improvements over the past 50 years compared to other industries. A recent study from McKinsey that looked at industries' move to digitization showed manufacturing near the top 3.3% investment, but the study put construction close to the bottom at 1.2% investment. Based on Construction Intelligence Center construction output for civil infrastructure, total infrastructure spend will total over $10 trillion for the next 5 years. Of this, 50% will be in roads and highways and approximately 25% for each rail and other, such as airports, ports, dams and inland waterways. And within these transportation projects, new construction continues to outspend maintenance activities of all types: repair and maintenance, refurbishment and demolition. Even though the majority of spend occurs on new construction, there is a much higher volume of rehabilitation type projects. In the US, for example, new construction projects have 4 times higher value than rehabilitation projects, but rehabilitation projects occur twice as much, and 80% of rehabilitation projects are carried out by local government. Add to this the unrelenting demand. The construction industry is a cornerstone to the industry and overall economy, contributing about 6% of global GDP. That's $10 trillion annual revenues. When you look at a construction site though, it can look like chaos. Projects are complex, in congested areas, and close coordination is required in real time. The Boston Consulting Group recently estimated that within 10 years, full-scale implementation of digital infrastructure delivery across the asset lifecycle could lead to annual global cost savings of $0.7 trillion to $1.2 trillion in non-residential construction. In the era of connection, the infrastructure design industry has a large opportunity to lead the transition to digitized processes, providing more value to their clients. The solution to the industry's challenges, as well as the business challenges of individual consultancy firms, is BIM. Building Information Modeling, or BIM, is an intelligent 3D model-based process that equips architecture, engineering and construction professionals with the insight and tools to more efficiently plan, design, construct and manage building and infrastructure. With BIM, you can improve project understanding and decision making, share and use the same consistent data across the project lifecycle from your desk or in the field, respond quickly to change with processes that are smarter and faster. BCG and McKinsey go further in defining what digitization means for the construction industry. It is enabled by fast acceleration of technology trends driven by cloud computing and mobile technology. By embracing BIM, civil engineers have a unique opportunity to lead the industry's transformation to a more efficient way of working. BIM allows for earlier design insight and decision making, allowing changes to be made when it's less costly. Because BIM automates the production and coordination of much of the construction documentation needed on the project, civil engineers and designers can spend more time on design and less time on tedious, resource-intensive tasks. Here's a stack ranking from the 2017 Dodge report depicting a stack ranking of the benefits of BIM. As we can see, BIM resulted in 33% fewer errors, 22% greater cost predictability, 21% better understanding, 16% improved scheduling, and 8% optimised design. In addition, BIM can help civil engineers address business challenges you are facing today. This includes winning new work, involving meet client demands for BIM deliverables, participate in alternative project delivery models, and effectively communicate design intent to earn stakeholder buy-in. Deliver higher quality designs. This means improved building performance via analysis tools and using visualizations and VR to experience your designs before they are built. Work more efficiently. This includes reducing errors and change orders, improving collaboration with engineers and contractors, and staying on time and within budget. And finally, expanding billable services, including extending services beyond design and into building operations with model maintenance. Also, recast advisory relationships with clients to deliver long-term value to assets. These industry trends create specific business challenges for civil engineering firms, including winning and retaining work, expanding billable services, increasing project complexity, meeting sustainable design standards, increasing demand for BIM, and hiring and retaining talent. Traditional 2D practices and siloed ways of working are no longer sufficient, and there is a growing recognition of the need for transforming how work gets done. Increasing BIM adoption by contractors, owners, and for infrastructure projects is evidence of this shift. Let's now take a look at different phases or aspects of an infrastructure project and how the Autodesk AEC package can help you, starting with surveying. By adopting BIM for surveys, engineers can convert high-precision surveys to detailed topographic data, utilize automation for data extraction from LiDAR, and implement drone innovation to supplement context models. Leveraging high-precision survey collection from GPS and total stations to build out existing conditions to begin the design process in Civil 3D. This is the first step to designing in context. Autodesk has created a powerful and easy-to-use workflow for reality capture in order to bring you a scan-to-BIM workflow. Autodesk has partnerships with every major hardware vendor, including both UAV, drone manufacturers and laser scanner manufacturers. Recap Pro has been designed for use by someone with no previous experience, so it's very user-friendly, and one-click automated workflows do powerful tasks like scan registration, which stitches multiple scans together into one point cloud, and intelligent cleanup services, which automatically remove unwanted noise. Perhaps most importantly, Recap integrates with all of Autodesk's key AEC design creation tools, so you can bring that reality data into the data creation tool of your choice, including lightweight point cloud, reduce original point cloud by 90%, automated data extraction, bare earth terrain, vertical point features and linear features, enhance existing conditions, use linear features to existing surfaces. Reduce survey effort. Reduce the time required to survey the site. Minimize the size of your survey crew. Improved safety with new methods of data collection. Limit crew activity on active construction sites. Add context to your design. We're the one-stop shop to manage your data. Quicker with cloud-based processing. Access to the standard data outputs, and quality and format you need so you can begin your design. Now let's take a look at how BIM and the AEC Collection can help you at conceptual planning. Aggregate data to create project context. Develop parametric roadway, bridge and drainage designs. Evaluate design alternatives. Perform analysis to optimize designs. And finally, communicate your design with videos and renderings. Create project context with aggregated data, including starting designing inside of 10 minutes with Model Builder. Aggregate terrain, aerial photos, GIS, CAD and BIM. Get started quickly with the ability to add more detail as needed. Quickly create and examine multiple design options earlier in the process. Quick geometry layout, intuitive model-based design, turning lanes, intersections versus roundabouts. Validate design in real time within context analysis. Dynamic quantities provided in real time. Profile optimization, intersection design, traffic simulation, and super elevation. Continue design in Civil 3D. Import InfraWorks model to Civil 3D. Continue detailed design and documentation. Bring detailed design back into InfraWorks for communication and collaboration. Quickly evaluate multiple design options through simplified watershed analysis, automated terrain analysis generating a conceptual watershed, automated culvert location and sizing based on user-defined criteria, automated placement and sizing of inlets and pipes for closed drainage, dynamic quantities provided in real time. Validate design in real time, integrated design and analytics process, real-time performance, feedback of drainage systems like hydraulic grade line, energy grade line, invert elevations, surcharge, etc. Import InfraWorks model to Civil 3D. Continue in Civil 3D Storm and Sanitary module which understands InfraWorks model elements. Continue detailed design and documentation. Bring detailed design back into InfraWorks for communication and collaboration. Enhanced interoperability brings Revit and InfraWorks together to perform more efficient parametric bridge design. Quickly evaluate multiple design options. Within InfraWorks, dynamic and intuitive layout of the bridge, automated design of components such as superstructure and substructure with parametric controls. Bridge components understand how they relate to one another, therefore they're dynamic in their behavior. Library of bridge components included with all the parametric controls required. validate design in real time, dynamic quantities provided in real time, built-in line girder analysis, interoperable with Revit and Inventor. Use Inventor for more complex geometry such as girders, piers and foundations. One-click push to Revit. Family support enables Revit functionality. Now let's have a look at how BIM and the AEC Collection can help you with your preliminary and detailed designs. Design in a dynamic 3D model-based environment. Design with contextual rule-based standards. Produce plans that dynamically reflect changes. Collaborate across multidisciplinary design teams. And centralized access to project information. Today, many companies have made the move to BIM. Civil 3D in the dynamic model provides an associative relationship between geometry, corridor model and plans, which enables productivity, reduced errors and emissions, and delivering accurate digital data to the field. Improve productivity by moving from 2D to 3D. Civil 3D dynamic modeling. Perform faster design iterations and streamline time-consuming tasks such as geometric layout and intersection designs. Interoperability with Bentley, Trimble and Topcon. Reduce errors and emissions. Associative labeling and annotation, standards checking, drainage analysis, design analytics and clash detection. Design to construction, quantities, reports, surfaces and 3D breakline data for survey layout and automated machine guidance. Automated sheet creation. Create plan, profile and cross-section sheets, dynamic view frames, dynamic match lines, dynamic link between design and plans, dynamic labeling on sheets, streamline plan set management. Interoperability. Downstream interoperability from InfraWorks facilitates reinforcement, detailing and documentation. Reinforcement. Place rebar into non-linear shapes. Plans generated from the model. Create more accurate, detailed documentation of concrete bridges and structures. Model elements are direct representations of information from the Revit model. And finally, let's look at the benefits gained from virtual design and construction. Perform model review, clash detection and collaborate. Create 4 and 5D simulations and communicate the project to owners and stakeholders. Navisworks allows you to aggregate over 50 file types from all major software vendors. Collaborate across disciplines with interdisciplinary coordination and constructability review. Manage risk with automated clash detection and reporting, resulting in reduced errors and emissions. .4D modelling allows stakeholders to visualise construction over the project duration to identify potential spatial or temporal conflicts in schedule. Adding a cost component to the process creates a 5th dimension, making a 5D model. Such 5D engineered models allow stakeholders to evaluate costs and model cash flows for each phase of construction. The key benefits are as follows: improved project delivery, improved communication, enhanced identification of errors, and improved visualization. What we've covered in this video merely skims the surface of what the Autodesk AEC Collection has to offer. How will you use yours?